Hello everyone, in today's video we are going to see what happens if we overdrive a capacitive dropper. So this is a very basic capacitive dropper circuit that currently glows at around 272 volts. It will also glow at, let's say, 110 volts or something like that, and most of the voltage drop will be across this capacitor. So we do have a couple of resistors on the other side. I'll be showing you with a picture, but in general we have a capacitor that drops most of the voltage, and we have a full wave bridge rectifier that will rectify the low voltage output to our LED output. But if you don't have any load, for example, if you don't have the LEDs, it will try to give the full voltage as output to the full wave bridge rectifier. And also make sure that you don't touch any of that circuit, because even though it looks like that the LED glows and it is low voltage, it is not, because the capacitor is not isolating the AC voltage. Just to make sure, we are going to use around 500 volts AC. We will see what happens to this circuit. So the transformer I'll be using can produce around 500 VA at 440 volts, but we are going to actually provide around 270 volts. The transformer will work perfectly fine. So the transformer can output about 1 amp of current if the power is resistive. First off, we have 3 multimeters here, and this multimeter is showing the AC voltage. This multimeter is showing the voltage drop across the capacitor, and this multimeter is showing the AC current. So if I turn my auto transformer on, currently we are around 13 volts, and the light is glowing very faintly. So it starts from around 14 volts AC. This will of course not work at DC, because the capacitor will just block that. At around 50 volts, the light is nicely visible, but it is quite faint. And at 50 volts, we are drawing around 1.67 milliamp of current. We are having 51.5 volt or something like that. And this multimeter is showing that we are dropping most of that voltage, which is 49 volts or 50 volts, something like that. So if I change the measuring mode to 200 volts AC, you can see precisely that it is 49.5. Note that this is not a true RMS meter. So if I slowly increase the volt to, let's say, 110, you can see that at around 112 volts, we are dropping around 110 volts. It makes sense because the LEDs do have practically around 2 volts forward voltage drop. So it is dropping around 2 volts or something like that. And we are drawing around 3.68 milliamp. And this is nicely visible. So if I increase that to, let's say, 210, something like that, we are around 220. And the voltage across the capacitive dropper is actually over limit. So I set it to 600. And it shows that we are dropping around 215, 216 volts, which makes sense. So if I keep on going at around 300 volts, this capacitor is rated for max 310 volts AC. So we are around 280 volts, and we are dropping around 278 or something like that. And the circuit is drawing around 10 milliamp at 305 volts. We are close to the capacitor's maximum limit. We are actually reaching higher than the rated voltage of the capacitor. And we are drawing around 10.2 milliamp of current at around 310 volts. And the capacitor is dropping most of that, and the LED is glowing. If we keep going to, let's say, 350, what happens? So we are around 351 volts. And as you can see that the light glows really nicely. The capacitor is dropping above its limit. If we again keep going to, let's say, 400 volts, we're around 405, something like that. And the whole circuit draws around 13.65 milliamp. And the capacitor is dropping most of the 414 volts, and nothing is happening. So let's increase that to 460 volts. And we can see that we are around 470 right now, and the capacitor is dropping most of that. We are drawing around 15.48 milliamp of current, and the LEDs glow perfectly well. So at this point, if I turn off the circuit and reduce the voltage, so if it's accidentally turned on, it will be pretty safe. And now if I touch something, nothing is actually hot here. So the full wave bridge rectifier, the resistors, nothing is hot. So again, let's turn this on. and increase the voltage to something like 500. As you can see that we have reached around 535 volts and we are drawing around 17.6 milliamp. Nothing is wrong, nothing is smoking, nothing is bad in here, and most of the voltage is dropped by this capacitor here. So that's quite interesting. And the thing to note that the capacitive droppers, even if they are rated for lower voltage, they can actually take higher voltage if they are good capacitors. Now there's a problem. If you go above a certain limit, the capacitor might blow up, and because I have a fusible resistor, that might protect it a little bit, but it is currently not limiting the current that much, and the capacitor is dropping most of the voltage. So if I keep turn this on for maybe few hours or even days, the capacitor will get slowly damaged, and because of the surges and high voltages, the holes inside the capacitor will get filled up by vaporizing the metallized layer from the other layers. So hope that makes sense, but we can actually cross the limit. Definitely this is not safe, this is actually damaging the capacitor, but it kind of works momentarily. So yeah, you can like really run capacitive droppers from 50 volts to 537 volts and nothing will go wrong. And if your actually target is around 500 volts, something like that, use a capacitor that can take that voltage. And currently this capacitor is rated for 310 volts AC, which is like some 400 something volts peak. So the peak voltage is something that matters. Because this is rated for AC, they have already calculated the peak, so we don't have to worry about that. So that's the thing. Hope you find this video interesting. Nothing blows up, nothing is hot, and everything is running okay. But this is dangerous. Just don't do that, even if nothing bad happens. So yeah, hope this was interesting. If so, please like the video, share the video, and if you have any suggestions or corrections, please let me know in the comment. And I'll see you in the next one. Cheers.